Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Firefly Aerospace fourth launch. So let's dive deep into it. So this FLTA-004, I have no idea who came up with the name, was launched on 22 December 2023 at 17:38 Universal Time Coordinate, and the customer was Lockheed Martin. Now this was the fourth flight. They had first boom, second boom, third successful, fourth this puppy, and the name of the mission was Fly the Lightning. And I do have to say they do put some effort in their insignia, so to say, and some good photography. So this is the fourth mission. Now, what was the payload? Well, payload is from Lockheed Martin tech demonstration, meaning Lockheed Martin is not doing a government contract. Basically, they want to showcase to the government and all their customers is that they got some new cool stuff. So what is this new cool stuff? Well, it's electronically steerable antenna. We generally use phase shift array on Earth for radars and mobile phones and Wi-Fi routers, generally not for satellites. Now, it does not mean there is none, it's just not preferred. But they wanted to show that there is a benefit of using this puppy, phase shift array, on a satellite. Now, what's the benefit? Benefit is faster on-orbit sensor calibration. If you have followed the story of James Webb Space Telescope, you must have known the fact that after it deployed everything, scientists were not given direct access to it. There was a team whose sole job was to make the basically observatory active. They took time for calibration, cool down, and a lot of other stuff. Same happens with all other spy satellite also. After the launch, meaning after, let's say, SpaceX or whichever company dropped them into the orbit, it's not like done, we good, we go. That's not how it works. Many times they take time to calibrate everything, even in optical spectrum. So for radio system, the idea is if they can shrink that calibration period, basically how long from basically deployment to actual use, that is a significant advantage. There is no point of like, oh, we just launched the satellite and now we have to wait for 1 week for calibration. There is a gap. So they wanted to close that basically ability gap. And how did they achieve something like this? Well, the core target was to keep the cost low. So for that reason, they utilized pre-existing satellite bus. There are many companies that make these buses, and the idea is very simple. They're gonna give you everything that is already built, already tested. All you have to do is put your payload. They're gonna sort the power output of it, solar panel folding and closing, and it has become a very big industry, very successful one. So they used Terran Orbital's Nebula series. Yes, the Terran Orbital is the company. They have series of this sort of buses. So they used one of those small satellite bus. So basically they just put the radio stuff there, classified stuff on top of it. And what they wanted to showcase with this is that they have speed. This whole project started 2 years ago. So from a brand new idea to physical launch, physically deploying in the orbit is only 2 years. Now that is very attractive to, well, everybody. Think about it this way, like you go to someone, it's like, hey, I want you to design a satellite for me, and they're like, okay sir, awesome, but it's going to take, let's say, 5 years or 4 years, versus 2 years, done. And be mindful, this is the first time they are doing it, so they are reasonably sure they can shrink that time even smaller, so maybe 1 year. So that's the idea of the payload, this puppy or this puppy. Now, what happened to the launch? Well, they did launch it, and basically everything on liftoff happened. Awesome. Mach 1 was achieved. Very awesome. Max Q, no problem. Main engine cutoff, no problem. Stage separation, no problem. Stage 2 ignition, flawless. Fairing jettison, no problem. Second engine cutoff, awesome. And then poof, something bad happened. Basically, it's supposed to take 1 or 2 orbit around the world, basically coasting phase of around 40-ish minute, and after that they had to do second stage reignition. It's a common sort of procedure. Even SpaceX does that in some requirements. It's a normal thing, it's done thing. But when they reignited it, it did not ignite, meaning everything after the orbital phase was fail. So basically till here their rocket was like awesome. After that it's like a rocket glitched, and without the second stage reignition, the payload was too close to low Earth orbit. Basically the orbit was not fine-tuned enough. They got to the orbital velocity, not to the right orbit which they needed to, which means that while the satellite is gonna be orbiting for a while, it's not gonna last as long as expected, meaning if their original calculation was like, let's say, 2-3 years, it may fall out of the sky in 1 week. We do not know. That's the classified part of it. So as of now, the best knowledge that people have is that satellite is in orbit, it is communicating, but how long it's going to be there, that's up in the air. They could be lucky. They could still get basically, let's say, time for calibration. So let's say worst case scenario, the old era of doing things, calibration took let's say 6 months, and they're like, hey, let's calibrate it in 1 day, and let's say it survived for 3 or 4 days. That's good enough. Again, ideally they would have loved to have that exact thing, but things happen. So it's a failure from payload point of view. From rocket point of view, it's partial failure because the first stage worked as it's supposed to. Second stage also worked very close to its intended use case, but things happen. So launch was partial success at best. Now, there is a very serious importance behind this because USA got a bitch slap. Now, that bitch slap happened with Space Shuttle era. Space Shuttle was bad, like flat out, it was bad. You may love it, but it was bad. Like from all points of view, economics, safety, everything, it was just bad. So after that bitch slap, they realized one very critical component. Thou shall not have single point of failure, meaning from now onwards, when America is going to rebuild their space wing, they're going to make sure that under no circumstances they should have one point of failure, meaning if this goes down, we did, that should not happen. So they should not go from, oh, we had our space shuttle to, we go down to this guy and like this guy is launching rockets, and again slowly increasing the price, and you can't do anything. So they made sure, like this is now ingrained into the space policy, that under no circumstance, no matter how good one thing is, you shall always have backup. They have learned it. And then relationship, basically these two people making love, USA and Russia making love, they got soured, they got divorced during Russia-Ukraine war. And then that fallout happened. The fallout was, technically America has a lot of rockets. Unfortunately, not all of them actually use their own liquid rocket engine. Many of them are coming from Russia or Russian design based. So that created an issue. So-called national rockets were not actually national. This made him very happy. So they reached to the same fallacy. One point of failure. SpaceX must work, otherwise there is no space wing in America. So that is flat out not acceptable. To solve that, basically space agencies are like working together. So Firefly is gonna get in bed with Northrop Grumman, and the idea is they're gonna rebuild this Antares Series 300 class of rockets with new engines. That engines would be provided by an American company, a privately funded company, so it would be efficient, cost effective, and no longer Putin dependent. So that was the idea. So basically they want to make sure that there is a series of rocket, not just one, series of rocket from different vendors, from different options, so they no longer reach a point where it's like, oops. And that's another reason why Boeing is still getting money for basically Starliner, even though Dreamliner, Starliner, I'm saying, basically Dragon is working, they're still getting for money for that reason. They have to make sure there must be 2 crew capsule. And on top of that, Firefly proved something very significant with their third launch, this launch basically, Nox launch. The idea with this puppy is that US Space Force is gonna give you a puppy, a box. That puppy in the box should get to orbit after they give you the box in 24 hours. Meaning if SpaceX have, let's say Space Force have already built a lot of naughty puppies and they're like, this is our puppy, go. So from them go to actual orbit should be 24 hours, and they achieved it. 24 hours. This is your box. I take the box. It's in orbit in next 24 hours. That's not fast. That's bonkers fast. That's almost teleportation level speed from satellite's point of view. We used to take weeks just to mount a damn thing, and now they are like, boom, orbit, go home. So that's the whole point of Space Force, US Space Force Agency. They're not focusing on the biggest and the baddest thing. They're focusing on agility. The idea is that during basically China's attack on Taiwan, China is going to blockade all their satellites. Until they do so, they do not know how the heck they're going to blockade it. So once the blocking happens, then satellite is going to tell it that's how you are blocking it. They will have that data. Now they're going to launch a new satellite to compensate for it. Now that time, basically soldiers without satellites versus new satellite going there and being deployed should be very quick, as in less than a week. Meaning ideally it should be 2 days maximum. So basically they are going from we need air support to we need space support very quickly. So that's why the speed of this sort of private enterprise is so important. And again, they will not even try to do this with SpaceX. SpaceX is too big. The rockets are big, the rockets are huge. So they need something far more agile. This is a cost-effective way of doing it. And that's why they are getting funding. Astra is also getting funding for that reason, but Astra's bank balance is not good. They have far better economic footing, let's just say. So it is important. You may think, who cares, like SpaceX, but like, no, they are far more important warhead compared to other things. Imagine it that way, like They can, what if they drop this time from puppy to orbit to 12 hours? Like, that's bonkers. So there is significant importance here. Now, what can we expect in the future? Well, reality is sitting in right now is that world is changing. As of now, we had the government era. Now that government era is dying. Basically, flat out, every governmental agency, be it whichever country, there are only few countries that have governmental agency, only few of them actually have rockets, but all of them are being phased out, not because of cost or something, it's simply because of incompetency. They simply cannot do what needs to be done. Look into SLS if you want to give yourself a heart attack. So, and more missions are switching. And this is the problem that America is worried about. It's like they are all switching to SpaceX. So they have to make sure that there is healthy competition. They have to make sure they have multiple options. And again, thankfully, seeds are being planted. With some patients, they are expecting in next 5 to 10 years, they should have some medium launch vehicle to light launch vehicle from multiple vendors. So SpaceX, Electron Lab, Firefly, that should happen. Like, to give you a context how bad it is, like people are selecting these three puppies rather than ESA or ISRO, is that ESA, again, has money, has resources, has time, has everything. They built a small rocket. Okay, awesome. They have a big Ares rocket, they have a tiny Vega rocket for small puppies. Now, this small rocket, which is a very small rocket, not like huge Starship rocket, it's a small rocket. They had one last mission under its belt. It's like, we have to finish this up and then we're gonna retire this puppy. Okay, cool, no problem. They can't do that right now. Now, why? They lost their balls. And I'm not joking. They had 4 balls, pressurizing tanks, and they apparently oopsed 2 of them. Now, again, that happens. This sort of thing is real, normal things. But here's the ironic part. They stopped the whole system. Whereas, like, they genuinely do not have a solution right now. Like, if you think this should happen, all they should have to do is like, hey, where is the spec sheet for this puppy? How the heck exactly we built it? Which is the nearest contractor for that puppy? And you rebuilt it. Like, they are wasting more time discussing what to do rather than actually solving the problem. Like, think about it this way. SpaceX only launched 2 Starship. But here's how quickly they can launch the 3rd or 4th one. Like, before ESA will have discussion, they will be like, yeah, bro, we launched it, bro. Oh yeah, that it blew up, no problem, bro. This is 4th one, 5th one, 6th one. Or even Electron Lab also has the heck, Astra had that sort of bonkers speed. So that's the whole point, where cadence from governmental agency is so bloated, so useless. Oh, and let's not even talk about Ares 6 rocket. They are literally blackmailing ESA. I'm not even joking, this is not me. ESA is literally getting letters where it's like, can you please increase our subsidy, because if you do not increase it, we'll shut down the project, basically Aryan Corporation, and yeah, you're not gonna have any rocket. That's why you must have multiple option. If you do not have multiple option, that blackmailing happens. So I'm not even joking, the rocket is already outdated, rocket is already useless. And again, the cost before subsidy was bad. Now again, they have minor subsidy, but now the subsidy has to be almost doubled. That's how bad it is, governmental agency. Like India built a small satellite launch vehicle, SSLV, small satellite launch vehicle. And the first one was a failure, no problem. Then they launched the second one, it was a success, awesome. But here's the gap between those two was almost 1 year. And the third one has not happened yet. The gap between governmental agency actually getting their act together and sorting something out is so large nowadays, is that I'm worried that by the time 3rd or 4th launch of this puppy will happen, I will have a new company to talk about. Oh, this new company came in, they made their stuff, they are now in orbit. That's why, like, flat out, the future has changed at this point in time. So any company that does not have launch cadence, they did. Basically, any company that is thinking about solid boosters. Solid boosters are awesome for missile, ICBMs. For rocket company that is dumping payloads into orbit, unwise to say the least. So that's the interesting future that we are going to. They lost their balls. So this was my presentation on basically the 4th launch of Alpha series of rocket. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.